Alaikum warahmatullahi wabarakatuh. Friends, welcome back to my channel. In my last video I discussed voltage divider network, how we can divide voltage using two resistors RL and R1 in series. We can say R1 and R2, and we can calculate it. But there is a backdraw in this voltage divider network. We discussed we have 30k resistor here, 10k resistor here. So RL is 10k and this one is 30k resistor with 1 milliampere current. So it will divide 30 volt here, 10 volt here. And we can determine the voltage, output voltage, V supply, I, the amount of current, R2 divided by I into R1, R2. 40 volt, 1 milliampere current, 10k resistor here, 30k resistor here. When we calculate it, it will become 10 volts. So I have this 30 kilo ohm resistor. We will use it. And then I have 10 kilo ohm resistor. So we will connect these two resistors in series. Now I have total resistance, that is 30 plus 10, it is 40 kilo ohm. And I have DC voltage, it is 40 volt. So from this voltage divider network, from negative to center point, I am taking 10 volt. That's good. It is according to our calculation. But imagine what will happen if this is without load. If I connect our load to use this voltage, this is 10 kilo ohm resistor and I want to use a 10 kilo ohm resistor here, because we have to take this voltage for some useful function. So I am connecting this 10 kilo ohm resistor in parallel. So we will see the result. Now I connected 10 kilo ohm resistor in parallel, because we have to take this voltage out. We have to take this voltage out. What will happen? What is the result on the voltage? In this case, it is 5.9 volts. This resistor will drop 34 volt. Before this, when this load was not connected, it was dropping 10 volt here. But when we connect two resistors in parallel, what happened? The voltage dropped. So this time R2, R1, RL. So R2 parallel to RL. So when two resistors are in parallel, the total resistance of this section will decrease. R2 multiplied by RL divided by R2 plus RL. So it will 10k divided by 10 plus 10, it is 5 kilo ohm resistance. So now the resistor here dropped. When it was one resistor, this is 10 kilo ohm resistor and this resistor is 10 kilo ohm. But when we connect in parallel, RT of this section, total resistance of this section will drop. It is 5.195 kilo ohm, because two resistors in parallel. So that is the reason the RT of this section will drop and total resistance will drop now. Before that it was 30 plus 10 kilo ohm, 40 kilo ohm. Now 30 plus 5, it is 35 kilo ohm. The second thing, because in series current have one direction, but in parallel current have two lines. The current will divided into two lines. We need 1 milliampere to drive the load here, because here we calculated with 1 milliampere. Here we need 1 milliampere for load and 1 milliampere for this R2. So IT will IR2 plus IRL. So it is 1 milliampere we need for load. 1 milliampere. So it will become 2 milliampere. Now we have to calculate the resistance R1 with 2 milliampere. In our last session, for an ideal voltage divider network, we need a current flowing from this, but due to this parallel load, the voltage dropped, current divided into two sections. So this drop voltage is called loading effect in voltage divider. When we connect the load V out with load, so the load voltage dropped up to 5 volt. Now we have to calculate it again with 2 milliampere. I out 2 milliampere from this point with load. Value of R1, because it have to drop the voltage, so value of R1 is equal to V supply minus V load divided by I3, that is 2 milliampere. But now 2 milliampere, 1 milliampere from here, 1 milliampere from here, and it will added at this point, and R1 will face 2 milliampere current, so it becomes 15 kilo ohm resistance. We have to remove this resistance. Now I connected this 16k, so now we will connect this 16k, okay, no problem, and we will check the voltage. There will a slight difference, but no problem, because the resistor value, it is 1k more. Actually it is 15k. So here it is 9.76 volt, because this resistance is 1k more. Now the loading effect of this resistor network is reduced. Now we are taking 9.76 volt. If I have 15k resistor exactly, then I should have here 10 volt. To overcome this issue, loading effect in the voltage, we have to calculate R2 in parallel with R2 with load resistance parallel. Then we have to calculate the output load. Now we can calculate the output voltage of this circuit after calculating the new resistance R1 multiplied by, now we have to calculate R2 parallel RL divided by I R1 plus R2 parallel RL. When we calculate it, 10 volt, so that is here it is 9.77 volt, because here we have 16 kilo ohm resistance instead of 15 kilo. Now we can calculate the power dissipation of this resistor with I square R formula. So we have to select now exact value for power rating of this resistor. I hope so this video is informative. If it is informative, hit the like button. If you have not subscribed my channel, subscribe it. If you want to watch my videos in future, you can press bell icon button. Thanks for watching. Assalamu alaikum warahmatullahi wabarakatuh.